Hello and welcome to the ASR Fintech. This episode, we cover on machine learning to detect SQL injection. The web explanation. Machine learning is increasingly utilized for detecting SQL injection. SQLI attacks by identifying malicious patterns in web traffic, database queries, and log files. This approach offers a more robust defense than traditional methods, which may struggle with evolving and obfuscated attack techniques. A few ways how machine learning detects SQLI in reference to data collection and pre-processing. By sources, data is gathered from various points including web application access logs, database query logs, and network traffic between the web applications and the database. By feature extraction, relevant features are extracted from this data, which can include query structure, presence of specific keywords, example, or behavior anomalies. Natural language processing (NLP) techniques, such as word-level TF-IDF, are often employed for feature extraction from textual data like SQL queries. In reference to model training, by labeled datasets, machine learning models are trained on datasets containing both benign and malicious SQL queries, often labeled as O for benign and I for malicious. By algorithms, various machine learning algorithms are used, including in reference to supervised learning. Some examples: support vector machines (SVM), random forest, naive Bayes, decision trees, logistic regression. In reference to deep learning, convolutional neural networks (CNNs), recurrent neural networks (RNNs) like long short-term memory (LSTM), and autoencoders. In reference to unsupervised learning, k-means clustering and autoencoders can be used when labeled data is scarce by identifying anomalies and hidden structures in unclassified data. Another way is classification and detection. In reference to classification, the trained model classifies incoming queries or log entries as either benign or malicious based on the learned patterns. In reference to action, if a query is identified as malicious, the system can either alert administrators, passive detection, or actively prevent the query from reaching the database server, active prevention. We cover now on the advantages of machine learning for SQLI detection. By adaptability, machine learning models can adapt to new and evolving SQLI attack techniques. By reduced false positives, advanced model, especially deep learning, can reduce false positives by accurately distinguishing between legitimate and malicious queries. By detection of obfuscated attacks, machine learning can identify complex and obfuscated attacks that might bypass traditional signature-based detection. A few challenges: by labeled data requirements, supervised learning models require large, high-quality labeled data for effective training. By computational resources, deep learning models can be computationally intensive, requiring significant resources for training and deployment. By evolving attacks, continuous monitoring and retraining are necessary to maintain detection effectiveness against new attack variations. A technology study is published on bbc.co.uk on June 9, 2025 headline, AI Agents Exploring the Potential and the Problems. The byline read, AI agents could save time and effort, but it could also raise many big questions, including ones of trust, control, privacy, and sustainability. This BBC study read, as generative AI systems evolve from chat-based tools into agents, understanding the potential and limitations of AI agents becomes increasingly important. Agents are claimed by many to be the next big thing in AI. We're told that these AI-powered autonomous agents will act on our behalf and book our holidays, writing our code, or completing mundane work tasks to enable us to spend our time on more worthy things. So, at the start of 2025, the BBC R&D's advisory team decided to look more closely at the technology and the issues raised by this rapidly developing technology to guide future research efforts and explore whether and how we might use agents in the BBC. It's important to note that this is a fast-changing landscape with new releases coming regularly from many different research labs. During our work, we saw major releases such as OpenAI's Deep Research and Operator, reshaping expectations of what AI agents can and cannot do. As a result, rather than attempt to capture the state of the art, this article offers a working definition of AI agents, explores what makes them distinctive, and highlights the challenges and limitations the technology may encounter in the near and long term. What is an agent anyway? Before turning to AI agents specifically, it's helpful to define what we mean by agents more generally. The word has been used in computer science for decades, but definitions vary widely. The simplest option is to think of agents as systems that have the power or authority to act on the world in some way. But this leaves many questions. Do agents have to act on behalf of someone? Do they really need actuators or sensors? A citation from research paper by authors Vitaly G. Lepin, Yulia A. Andrusenko, Danila E. Surenkov, Dania A. Fedesh, Artem A. Solomyanko is published on ResearchGate.net in September 2025, titled Research of Machine Learning Methods for Detecting SQL Injections. The abstract read, this article explores modern machine learning techniques for detecting SQL injections, one of the most common cybersecurity threats. It examines approaches based on neural networks, principal component analysis, and the use of KNME platform. The article analyzes the effectiveness of various algorithms and provides recommendations for the implementation in real-world scenarios. The findings demonstrate the potential of machine learning to enhance the security of web applications against SQL injection attacks. Neural networks and PCA-based algorithms have shown significant accuracy in classifying malicious requests. The use of the KNIME platform has simplified the process of model development and testing, making it a promising tool for cybersecurity professionals. Future research directions include integrating these methods with other technology such as user behavior analysis and machine learning. This has been Dr. Alexander Solomon reading you the ASR Fintech covering on machine learning to detect SQL injection. For transcripts and related links, visit alexandersolomonreport.com. Once again, we credit mention for information sources of Google, bbc.co.uk, and researchgate.net. Thanks for watching.